So the time has finally come to do some ABS. Yeah, so right back all the way through, right back from the beginning, one of my goals has been to print parts in ABS, because that's kind of the material that a lot of the parts that I'll be printing need to be in. And if you've watched any of my previous videos, you'll know that I've mentioned this probably in every single video. Now, I guess it's no secret, but to print ABS, you need some ABS. So I thought I better order some. I decided to go for some cheap stuff from eBay. Just for playing around with, really. Not sure if that was a good idea or a bad idea. But anyway, that's what I did. And I've ordered some sort of fluorescent green stuff which matches the printer parts, so that if I have to reprint any of the actual printer parts that were done in ABS originally, I can do that. So I went ahead and ordered some, and delivery day came, and with much excitement I opened up the box. Yeah, so it turns out the seller doesn't actually stock ABS, and rather than remove that option from his selling item on eBay, he just sort of sends out PLA, hoping that maybe nobody will notice. So that kind of introduced a bit of a delay in me getting this video out. I would have hoped to have done this video a little bit sooner, but I needed to order some actual ABS from somewhere else, which did actually arrive. And well, at least it says ABS on the packet. Yeah, thought I'd better check. It says ABS, so hopefully it is ABS, and it's in yeah, the lovely green colour again. So I think we need to get on with trying to print ABS. Let's open it up. I have an opening implement here. It's quite nicely wrapped. It's got some silica. Which reminds me, I have also prepared a little airtight tub with a rather large bag of silica in there to try and keep the water out of it, as ABS is hydroscopic, which is a good word for a Sunday morning. Without further ado, I think we'll load this into the printer and start having a go at printing. Right, well, that's the ABS loaded into the printer, and I think probably what we need to do now is to have a model to print, which is going to be a sort of little test piece that I've knocked up. And yeah, so let's have a little look at my initial slicer settings. Okay, so we're going to need something to print, and here is my little test part that I've created. There are plenty of these around on the internet. I just wanted one that's going to be relatively quick to print, but will show me the kind of things that I need to know. So basically this big area here, well, I say big, it's not that big, the whole model's pretty small, because I want it to print quick. But this flattish area here will give me nice first layer lines to sort of judge to see how well that's knitting together. We've got some bridging here, and that's pretty much the extent of the bridging I'm going to be doing. And just in here we've got some overhangs. There's a 45° and a 35° overhang to see how that works out. We've got a solid wall here, so I can see the sort of surface finish going up. And as you can see, these are fairly narrow. I think the width of these is something like 432 mil. So that's very narrow and relatively long. So it's got quite a small footprint compared with the amount of material being printed on top. So it's almost guaranteed that these will lift off of the heated bed, I expect, without some kind of enclosure, and maybe even then. So it's probably quite a good little test to begin with. So yeah, let's have a little look at the print settings. So these are going to be my sort of first attempt stab in the dark settings for ABS. They are a combination of where I arrived so far on my PLA settings, where that's relevant to ABS, mixed in with some of the Prusa defaults from Slicer or Slick 3R. You might notice that despite what I said in earlier videos that I would stick with Slicer rather than Simplify 3D, I have in fact moved over to Simplify 3D. The only real reason for this is that it has a much better visualization of the G code, and I was using that to tune and arrive at some PLA settings, and basically the settings really do not copy across from one slicer to another. So if I have any kind of advice here, it is to pick a slicer and stick with it, because you will get everything set up how you want, and you're probably going to have to redo all of that work if you move slicers. So kind of by accident, I just carried on setting things up in Simplified 3D, and so now I'm kind of stuck with it. So let's have a look at the settings that I've thrown in. Obviously I'm leaving my nozzle diameter at 0.4. We're going for a 0.45 mil wide extrusion width. This is all exactly as I have for my PLA. I've reset my extrusion multiplier to 1, so we're basically starting from scratch, and we'll see how that works out. My ooze control is also as I would have for, well, that's basically defaults. Some of the PLA materials, I've changed the ooze control, and some of them work fine like this, but we're getting ahead of ourselves. We're really only looking for the first layer here. So on the layer settings, obviously I'm going for a 0.2 layer height. I'm not really interested in the, the solids yet. We'll leave that. First layer height I leave at 100%, which I'll discuss a little bit more in a second. First layer width. Now, all of these settings, well, actually not the first layer speed, but these two settings here, the layer height, first layer width, are a little bit, well, I would say I needed to be a little bit cautious, because they didn't do exactly what I thought. I would have thought, for example, the first layer width would force the width to, basically extrude more filament. Well, that is sort of partly true, but it also increases the distance between the strokes. So it's a little bit counterproductive for what I want. First layer, you'd kind of think you want to squeeze out a bit more filament to get it all nice and laid down thick, but actually this does give you slightly thicker first layer, but it also increases the gap. So yeah, bit counterproductive. So I just leave these two at 100% and 125%, which is exactly how I have PLA. First layer speeds at 50%, which we'll have a look at the speeds in a minute. Everything else is the same. Additions, I'm just printing a simple single skirt around 5mm away, so exactly what I do with PLA. Nothing changed for the infill, we're not using any support. So for the temperatures, I've literally just nicked these from Prusa's default ABS settings in Slick 3R or Slicer. So I've set the heated bed to 100 degrees C. The primary extruder, my ABS filament has printed on it something between 220 and 260. I'm going to go for 250 and see how we get on there, and that's going to be for all layers, as is the temperature of the heated bed. The cooling is turned off completely, and for my G code, this is all, I don't really change any of this, this is all unchanged. So, and this is the same as my PLA. Now, basically, the important one here is the Z-axis offset. I have played around with my the configuration H in Marlin, so that when my bed zeroes on the Z, it is exactly 0.05 millimeters away from the bed. And when I say the bed, I mean the Captain tape that's on the bed. The reason why I've set it up like this is because I also have the setting that you can't drop below this point. So if we were to try and set anything lower than that point in here, it just won't do it. It will just go down to the minimum, which confused me for a while. I was increasing this or decreasing it, trying to push it further towards the bed, and nothing was really happening. And that's because the firmware wasn't allowing it, although it was not really telling you, but it just wasn't getting any lower. So I figure that I'm never really going to go any lower than 0.05 mil away from the bed. So that's what I've set everything at, and I'm setting that offset here so that when the first layer prints, which will print at a 100% of this, So it'll print at 0.2. What that means is in G code it will go down to 0.15, which will actually put it 0.2 away from the captain. I think maybe that makes sense. Who knows? Maybe I'll do a video on this because I played around a fair bit with the Z-axis offsets, and yeah, this is what works for me. It gets it nice and close to the bed. Well, it gets it exactly what you're requiring, or what you're stating here, away from the bed. So that should give us a decent first layer. It may be that we need to squish it even more, but seeing as this is our first go, we'll leave it at that. So for the script, okay, well, I've worked quite a lot on my starting script. None of this is relevant specifically to ABS. This is what I use all the time. Basically, it's just doing obviously a homing and a bed leveling, and then it's priming the nozzle. The end script does nothing either, really. It just extracts the filament out and moves the hot end away from the print. You will also notice here that it shuts down the printer at the end, and this won't do anything right now because I'm testing out my power controller. That is why that's there. So on the other, this is where all the speeds are. Now I have set this back to 40 millimeters per second for these tests. PLA I've been running at 60 millimeters per second, and yeah, I guess you probably would see an increase in quality if I slowed it down, but I'm not so bothered with surface finish. So I've been doing all my stuff at 60 millimeters per second and I haven't had a problem. Nothing else here has changed from my PLA settings. That's all the same, and as is the rest of this. The one thing that I will say is that I've changed for ABS is because I've reduced my speed to 40 millimeters per second, or the default printing speed to 40 millimeters per second. I have increased this to 50%, because when I run it at 60 millimeters per second to make sure I get somewhere around about 20 millimeters per second for the first layer, I have to change that to 40. So I've just tweaked that back to 50, so I'm still at around about 20 millimeters per second for the first layer. In advanced, there is nothing particularly interesting here. These are set exactly how I have them for PLA. So I've saved that as a preset, and I've just called it ABS Test 1. Now for this first print, I'm really only going to be interested in the first layer or so. So I'm going to leave it at that because I'm going to stop the print after it's finished the first layer. And then after that, after we get the first layer right, anyway, hopefully if we can get the first layer right, I'll add some additional processes here to print these different layers at different, or these different sections going up at different temperatures to see where we are with the temperature. But for now, we'll just leave it with that single process, so that it's going to be printing at 250 degrees. And let's slice it. There it is, all sliced up. So let's save the G code. And yeah, we'll call this test 1 so that we know which settings we used. Save that out. And because the printer's all set up and ready to go, I will just find that file here and I shall copy it across to the folder that Octoprint is watching for new prints. So we'll just stick that in there. And all being well, there it is, it's popped up in Octoprint, and we'll just hit the print button. So we're off and running, well, sort of. Yep, it's doing its thing. It's set the heated bed at 100 degrees. So let's go and see how it gets on. Okay, so it's going to carry out the start G code, which is basically homing, which it's doing right now. Then it's going to do a bed leveling, and then it will heat up the hot end. Yeah, it's going to basically move the carriage so the nozzle is hanging off the edge of the bed. It will heat up the hot end so that anything that oozes out kind of sort of falls off the side of the bed. It will then squirt, well, prime about 20 mil of filament through, just to make sure that the filament's ready to go. It will then do a priming line just slightly on the bed, and it will then get printing. So let's have a little look at that. So it's now finished doing the first layer. It's moved on to the second layer. So I'm going to cancel the print and remove it very carefully from the bed so that I can take a closer look at what's happened with the first layer and see where we are getting on. Right, so here it is. I have no idea what magnification we're at here, but we are magnified. Yeah, surprisingly good. There's not a whole lot wrong with this first layer. As you can see, it's all nicely knitted together. We've got slight gaps here, but you're always going to get very slight gaps just because of the nature of the nozzle shape, really. So in terms of distance away from the bed and extrusion, we are pretty close. I would say, looking at some of this, and particularly this down around here, we have a slight amount of over extrusion. You can see where the nozzle's been dragged through some sort of surface filament as it does a movement over to here. And yeah, you can sort of see that it's slightly lumpy where it's doing the infill there. Around the holes, again, you can see here it's just a little bit over extruded. Yeah, very slightly. But we don't want to take the extrusion away too much because we've got a nice, you know, this is all knitted together quite nicely. Got a nice few strands of dust and hair and stuff in there as well. So I think basically, apart from a slight amount of over extrusion, we're good to go. So make a slight change in the old Jobby Doobry. So we'll exit out on the preview and let's just put in 0.98 and see where that gets us. So that'll be fine. Now what I'm going to do this time is start playing around with some temperatures. So we will add another process exactly the same, except I will set this temperature to, what should we do? Let's do bottomish, so 230. Yeah, we'll add another one and we shall do the temperature of this one to 240, and we'll add another one and we'll do this temperature at 260, and yeah, that should do, I think. So what have we got here on the temperatures? We've got the first set at 250 and we shall let that run to 7 mil, which is actually in there already, bizarrely. Which is the distance? Okay, let me show you which is the distance. That's not very good. Yeah, can we see that? Yeah, basically it's 7 mil from the very first layer up until this point here. So we're basically getting these overhangs in at the first temperature, and then I think we have every what is it, 4 mil, I think. Every 4 mil we've got another test, so we'll change the temperature every 4 mil. So process 2 we shall change to start at 7.01 and go up to 11. Third process we shall start it at 11.01 and go up to 15. And lastly, let's start this one at 15.01 and basically go completely to the end from there. And this will be at 260. Okay, so that's all good. We will just create the old G code. We will do all processes layer by layer. And ooh, there that is. Okay, so let's save this out and we shall call it the same. We haven't renamed it, so we'll just call it test 1A. Save that out. Let's go into the old Octoprint a minute. We will delete that as we're not going to be using that anymore. And where are we? Here we go. And that needs to go in there. And load and print. So let's see how we get on. Okay, so here it is. I'm sort of very surprised that this came out well, as good as it has, really. Yeah, there was a slight amount, and you can probably just about see it. There's a slight amount of lifting towards the back here, but well, as you'd expect, really, that's pretty thin and pretty long. So as it's printing all of this and this is cooling down and contracting, it's basically lifting that off, which is absolutely to be expected. But I expected it to be a lot worse, and I expected it to lift so badly that it would lift the whole thing off the bed and it wouldn't complete the print, but that didn't happen. Generally speaking, I think it's got a slight amount of over extrusion, but nothing that sort of really affects anything much. But if you want to be perfect about it, you could reduce the extrusion multiplier a little bit more. The solid wall, and I don't really know how best to show this, is, yeah, the quality's pretty good considering. Obviously this is where all of the what do you call it, this is where all of the crossings happen, where the nozzle moves from one column to the next column to the next column, all happens at the front. Therefore you can see a certain amount of snot in here. Let me just make sure we are focused. So you can obviously see a certain amount of snot at the front there, where it's sort of retracting and restarting again. But yeah, in reality that doesn't really happen. Well, certainly in the parts that I make, that doesn't really happen that way very often. The bridges are not bad. Obviously this one here, which I think is 2mm, is it? Well, it might be 3mm. 3mm bridge, yeah, it's fine. 4mm, I think, maybe that's 5, and this is 8. I think that's about right. Maybe 3, 5 and 8. In fact, even the 8's pretty much okay. One thing that I do notice is that it really has made no difference anywhere whatsoever what temperature it is printed at. Bear in mind that the base up to this point is at 250. From here to here is 230 and 260 for the rest of the way up. And yeah, it hasn't really made much difference. So you can see some stringing obviously on this big bridge here, but it hasn't really made any difference. There is a little bit of stringing across where it goes across here, but they're literally like very fine hairs, no major issues there. So if I can move this out of the way so that we can have a look at the overhangs, yeah, they're pretty bad in terms of quality, but they haven't failed to print, which is the most important thing. They're only really bad because this is so thin, there's so little material around them. But again, the temperature really has made next to no difference whatsoever to the you know, the quality of those. They all look more or less the same to me. So yeah, at least I can see that I can get away with a 35-degree overhang. It may not be entirely pretty, but it will work. And yeah, that's about it. The bottom is lovely. There's no issues there. It's all nice and smooth and mirror-like. So, well, apart from where it's hit the overlap in my Captain tape, the holes are perfectly fine. It's all flexible. As you'd expect. As you could see a minute ago, it's got a good amount of flex before snapping, unlike PLA, although you may be able to do that with PLA, I doubt it. Yeah, so that is my first full ABS print, and I'm sort of happy. Well, that didn't put up as much of a fight as I was expecting. Yeah. After all the things I'd heard about printing ABS, I really didn't think that I would get there that quickly, which was kind of why I made the video, because I thought there was going to be some more tweaking needed. I mean, okay, time will tell. Need to run a lot more different prints through it. I'm not going to do them just because, but as I need to print stuff, I'll see how they come out. And yeah, but well, it's the first print, and it's basically just needed some different temperatures and a little bit of adjustment on the extrusion multiplier. So I was going to build an enclosure, which I probably still will do, because no doubt it will help keep things flat. I mean, it did lift. It didn't lift off the bed completely, which was kind of what I was thinking would happen. But it did curl up at the edges, and you know, obviously if that's critical for the part to be flat, then I don't want that to happen. So I probably will still throw together an enclosure and see what kind of improvements that gets, but obviously it isn't needed to print at least that part in ABS. So I have also one in PLA, exactly the same part in PLA. The differences really are just in the overall print quality, which, well, I think is a given for ABS. Generally speaking, they're pretty much the same. The edges are a little bit more lumpy. Looks a bit more like melted plastic than PLA does. It sort of gives a good representation of being a nice, sharp, solid edge, whereas ABS not so much. Whether that's down to, you know, my setup here or my settings, I don't know. The ABS is definitely good enough for my sort of print quality requirements. Well, the bridges, not too much difference between the bridges, to be honest. The PLA is perfectly level, where the ABS does droop slightly on the bridge. The overhangs is a different story altogether. The PLA is very clean, and the ABS not so much. One thing that does bear out in reality is the theoretical densities of these two, and that is one of the main reasons why I needed to get ABS up and going. You know, the theory for once does bear fruit into reality. PLA is basically 20% more dense or heavier than ABS. So I am, you know, it's very difficult because you've got different amounts of infill, different perimeters on a different part. So actually working out how much filament is going in is pretty tricky until you actually have designed a thing. And then the point being is that I want to know at the design stage how heavy something is going to be. But what I'm doing is I'm keeping a sort of running average total, or a running average of my volume versus density, so I can over time build up a more and more accurate figure of density in kilograms per meters cubed. And so far what I'm seeing is that PLA comes in at about 1026 kilograms per meter cubed, and ABS comes in around about 900 kilograms per meters cubed. So that is a significant difference if weight's an issue. So yeah, I think that's probably a long enough video for now for producing one small test print. So I will keep, you know, I'll do some updates if I run into more problems printing ABS. If I don't run into any problems, then there's nothing really there's nothing really for me to put up there in case it helps anybody. This will be it. I do expect I'll run into some problems though. So yeah, that's it for now.